Cytokines in Crohn's disease. Unraveling the molecular immunology behind the chaos. At the microscopic level where the immune system choreographs its intricate ballet of defense and regulation, Crohn's disease stands as a dramatic example of what happens when that delicate choreography collapses into chaos. The body, in its relentless quest to protect itself, turns its arsenal inward, unleashing an inflammatory storm that scars the intestinal walls and leaves behind both physical and immunological wreckage. The cytokine storm. Within cytokines, those small but mighty proteins that act as the immune system's messengers are at the heart of this storm. They transmit signals that tell cells when to fight, when to heal, and when to stand down. But in Crohn's disease, this communication network goes rogue. Instead of maintaining balance, pro-inflammatory cytokines such as tumor necrosis factor alpha, TNF-A, interleukin-6, IL-6, IL-12, and IL-23 surge uncontrollably, creating a self-perpetuating cycle of inflammation that damages the intestinal lining, disrupts microbial harmony, and overwhelms the body's ability to restore equilibrium. The molecular tug-of-war. At the molecular level, Crohn's disease can be viewed as a continuous tug-of-war between the Th1 and Th17 immune pathways, both of which rely heavily on cytokine signaling. TNF-A activates macrophages that secrete more inflammatory mediators. IL-12 promotes Th1 cells to release interferon gamma, while IL-23 fuels Th17 cells that produce IL-17 and IL-22, perpetuating the recruitment of neutrophils and other inflammatory agents to the gut mucosa. These cytokines, though individually vital to defense against pathogens, together form a network of overreaction, where the immune system fails to recognize when the threat is gone, driving chronic tissue damage and ulceration. The genetic and environmental web. Underlying this immune chaos is a web of genetic predispositions and environmental triggers. Mutations in genes like NOD2, ATG16L1, and IL-23R can alter how intestinal cells sense bacterial components or regulate autophagy, thereby priming the immune system for exaggerated cytokine responses when confronted with normal gut microbes. Add to this mix external factors such as diet, stress, and antibiotics that alter the microbiome, and the result is a molecular environment where cytokine signaling spirals out of control, turning localized irritation into a full-blown autoimmune-like assault, targeting the messengers. Modern therapies aim not to silence the immune system entirely, but to recalibrate its conversation. Anti-TNF drugs such as infliximab and adalimumab intercept TNF-A before it binds to its receptor, thereby breaking the cycle of inflammation, while newer biologics target IL-12 TARN23 pathways, like ustekinumab, to block the dual signaling routes that feed Th1 and Th17 activation. The emerging field of JAK inhibitors also offers promise, as it seeks to disrupt the intracellular transmission of cytokine signals, effectively dimming the volume of inflammatory chatter without shutting it off completely. Toward molecular balance. As researchers continue to decode the immunological signatures of Crohn's disease, it becomes increasingly clear that cytokines are both the villains and the victims of a miswired system. They are essential for defense, but devastating when unregulated. The future of Crohn's therapy lies not in total suppression, but in precision immunomodulation, a strategy that recognizes the nuance of molecular balance, where every signal must arrive not just at the right strength, but at the right time. The takeaway. To truly understand Crohn's disease is to grasp that beneath its painful symptoms lies a molecular conversation gone awry, where cytokines shout when they should whisper, and cells attack when they should heal. It is a story of miscommunication at the cellular level, of chaos born from the very molecules designed to protect us, and of science's ongoing effort to restore harmony to a body that has forgotten how to listen to itself.